Hello Math 1093, this is Dr. P with Sums and Products. So here's a puzzle. I gave you this expression here. U and V are both greater than 0. They're real numbers greater than 0. B is just some real number. I should probably write down what that is. B is greater than 0, but not equal to 1. We can always define a logarithm to any given base as long as that base is positive and not equal to 1. Anyway, the puzzle is, how do we write this expression as a single logarithm? So log base b of something. Okay, now depending on your prior mathematical experience, you may know of a way to do this, like you may know of a formula for this. But I want to talk about how we might think about this if we didn't know of a formula. All right, so for this, I just want to think about what we can figure out about this expression, log base b of u plus log base b of v. So one thing that we've been doing when we encounter a problem involving logarithms or exponents that we can't seem to unpack is we use the inverse properties of logarithms. So just as a review, the inverse properties of logs. Let's put this in a little box here. So one of the inverse properties of logarithms is that I know that b to the log base b of anything, let's just call it x for now, is equal to x. And I also know that log base b of b to the y is equal to y. These two things are always true as long as, as long as x is greater than 0, because I can't take the logarithm of anything equal to 0 or less than 0, and as long as y is any real number. Okay, so I just want to make sure that that's been stated. Okay, so anyway, we're going to use one of these inverse properties of logs to see what we can figure out about this expression, log of u plus log of v. All right. So what I'd like to try doing is just see what happens if I take b and raise it to this power, log base b of u plus log base b of v, and just see what happens. Now, why am I throwing an exponential at this? I don't know. I've got logarithms, and I figure I can probably undo logarithms with an exponential. That's sort of the idea there. What does that equal to? Well, I know that I have an exponential, and in the exponent I have, sorry, I probably shouldn't mark that there. It looks like a plus minus. I don't mean for it to be a plus minus. What I mean to say is that this is a sum of two exponents, and I know that I have a property that says b to the x plus y is equal to b to the x times b to the y. So I'm going to use that here. I know that b to the log of u plus log of v is b to the log of u times b to the log of v. There we go, that's a v. And now I can use the inverse properties of logs to simplify both of these. I know that here I have an exponential and I have a logarithm, and those two processes cancel each other out. Same here, I'm taking v, taking the logarithm of it, and then taking the exponential of it. Those two processes cancel out. So that first piece is just u, and that second piece is just v. So what I have here is u times v. But now, wait a minute. I know that b to this exponent here gives me this power. And if I have an exponent here and a power here, then that means that I can write down an inverse statement. I can write down that the logarithm of that power, uv, that the logarithm to the base b, that is equal to this exponent. It's equal to log base b of u plus log base b of v. Okay. Now, if that last step didn't make sense, which that is kind of a tricky step there is another way that we could reach this conclusion. We could take this equation that we've developed, which says that b to the log base b of u plus log base b of v, that is equal to u times v. This is known because those are the two things we got equivalent in the previous few steps. And now I can apply the function log base b to each side, as long as I'm making sure to apply it to the entire side. So log base b of this whole thing, b to the log base b of u plus log base b of v, is equal to the log base b of uv. The left side, the exponential and the logarithm cancel each other out. Those two inverses undo each other. So I just have over here the exponent, log base b of u plus log base b of v. And on the right side, I just have log base b of u times v. So this is actually kind of nice. I get this result that tells me that the sum of two logarithms can be written as a single logarithm. It is the logarithm of the product of these two powers. So in other words, if I think of these as exponents, this is an exponent, this is an exponent, then the sum of these two exponents corresponds to the product of the two powers, u and v. Which is kind of nice. That feels like a part of my universe fitting together. Okay, so here's an example of where we might use something like this. So actually, sometimes we use this property to go from a sum of different logarithms to a single logarithm, and sometimes we use it to go the other way. In calculus, a lot of the time we use this property to go from here to something simpler like this. For example, suppose I give you the logarithm base b of x squared plus 3x. One thing that we might do in calculus, just because it gives us easier expressions to deal with, is we might say, well, that looks to me like the log base b of a factorable expression. That factorable expression is x times x plus 3. And then I can use the product property to say, well, this is a product of powers, because what goes into the logarithm function is a power. That corresponds to the sum of two exponents. That is, it corresponds to the log base b of x plus the log base b of x plus 3. And that's using this property here, that's using this thing right here, where u is x and v is x plus 3. All right, so that's an example of how we might use this property. All right, what we do in this section is going to seem a little bit unmotivated. Why would we care whether we have one log or 19 of them? Sometimes one is easier to deal with, and sometimes 19 simpler ones is easier to deal with. It's kind of like this funny internet joke. Would you rather fight, would you rather fight one horse-sized duck or 100 duck-sized horses? Sometimes you might prefer one, sometimes you might prefer the other one. Also, I don't know why we fight horses and ducks. That doesn't make any sense. Anyway, I'm digressing now, but hopefully this video helped to convince you that there is some reasoning behind this idea that the sum of two logarithms is the same as the logarithm of a product of two things. We'll talk about it more in class.